Welcome to The Explainer. We are diving into something truly mind-bending today. We're going to explore how a completely dormant 30-year-old internet protocol has suddenly been revived to do something it was honestly never originally able to do: orchestrate physical reality. We're talking about taking abstract digital truth and using it to command actual physical machines sitting right there in your living room. It's a wild ride.
To really grasp the magnitude of this breakthrough, we actually have to start with a digital cold case. It's a genuine 30-year tech mystery. Why did a foundational piece of the internet's architecture just gather dust, while the rest of the web completely exploded around it? It's astonishing when you think about it. The pioneers of the internet foresaw exactly what we needed. They built a placeholder for it, and then, well, absolutely nothing happened.
So, here is our roadmap for today. First up, the HTTP 402 fracture. Second, bypassing Ricardian complexity. Third, the chopsticks design solution. Fourth, LIFO JSON state trees. And finally, physical execution with Cheerbot.
All right, Section 1, the HTTP 402 fracture, a 30-year digital gap.
Back in 1996 and 97, internet pioneers, we're talking folks like Tim Berners-Lee, actually reserved this exact HTTP 402 status code specifically for native web transactions. By 1998, WebDAV had explicitly solidified it as payment required. The creators knew even back then that we'd eventually need a built-in way to pay for things natively on the web. But then there's this massive 30-year gap. Literally nothing happened until the X402 protocol finally arrived in 2025 to breathe life back into it.
Moving on to Section 2, bypassing Ricardian complexity and escaping legal bloat. For years, engineers were trying to build direct, on-chain payment protocols, but they kept hitting this wall of what's called Ricardian complexity. Imagine you're just trying to buy a simple pack of gum, but to do it, you have to bring a team of lawyers, draft a 50-page legal document, and get a notary to stamp it right there at the cash register. It was just this impenetrable brick wall of theoretical bloat. But then you have the alternative, modern webhooks. They are lightweight, surgical, and incredibly fast. The engineering world finally realized you just don't need all that heavy legal bloat when a simple digital tap on the shoulder does the job perfectly.
Which brings us to Section 3, the chopsticks design solution, a truly surgical fix.
This brilliantly illustrates the entire philosophy behind it. Think about it. You wouldn't build $1 million hyper-complex robotic arm just to pick up a single piece of sushi, right? No, of course not. You just use two simple sticks. That is the complete essence of chopsticks design. The X402 protocol applies this exact philosophy. Instead of dragging around this massive, monolithic smart contract system full of legal bloat, it simply relies on existing digital tools. Specifically, it uses those early 2010s webhook architectures in a beautifully straightforward way.
Let's actually walk through this ingeniously simple client callback loop. Step 1. The server doesn't panic and try to execute some massive smart contract. It just triggers a 402 status code demanding proof of payment. Step 2. An autonomous agent, or the client's wallet, steps in and signs a cryptographic proof of that payment. And finally, Step 3. The client simply retries the exact same HTTP request, handing over the receipt. The server sees the receipt, verifies it, and instantly unlocks the resource. It's a totally deterministic, event-driven loop that completely bypasses the mess and creates an immutable lock-in. Boom, done.
Section 4, LIFO JSON state trees and total determinism.
Historically, trying to map distributed digital data to actual physical machines, well, it was chaotic. If you rely on traditional event-driven programming, a single delayed signal can completely ruin an entire sequence. To fix this, the architecture strictly pivots to a LIFO, last in, first out, JSON state tree. Because the very last item to go in is always the first item to come out, you unlock this incredibly efficient single-entry bookkeeping. You only ever need to query index 0 to get an immediate, flawless mathematical proof of the system's state. So the absolutely crucial point here is total determinism. There is zero ambiguity. The state is either mathematically true or it isn't. No in-betweens, no guesswork. We have now locked down absolute digital truth. By using this bit-perfect tracking of state transitions, we completely eliminate the chaos of traditional event-driven data mapping. We've set up the exact foundation needed to perfectly manipulate the real world without things getting messy.
And finally, Section 5, physical execution with Cheerbot. Enter the Cheerbot. Meet the Flow X402 Cheerbot.
It's this awesome 3D printed collectible desktop shell, and tucked right inside, it houses a little Raspberry Pi acting as a localized microhost. It's actually designed as a free open source alternative to a smart speaker. But here is the kicker. It isn't just a fun little toy. It is a fully functioning robotic vending machine that acts as the physical switchboard for the entire X402 protocol we just unpacked.
Let's see how this all builds together into physical action. The CheerBot sits there on your desk, constantly reading that mathematically pure LIFO JSON state tree we were just talking about. When a verified digital tip or payment hits the webhook, the CheerBot reacts instantly. It translates that bit-perfect digital truth directly into electrical signals sent straight to the tiny GPIO pins on the Raspberry Pi. Those metal pins are basically the physical nervous system of the hardware. They shock the bot into action, spinning a motor, turning on a light, or dispensing an item to literally spread Cosmo Cheer right there in your living room.
There's this incredibly profound quote from the architecture documentation that perfectly frames what we've achieved here. It states, "The human pilot applies the intent, but the agent cell executes the sweat, bridging that massive gap between messy human desire and strict deterministic machine execution." You see, humans, we're messy, we're imaginative. Silicon, on the other hand, is cold, rigid, and strictly mechanical. But by using exactly formatted text, LIFO data trees, and physical GPI pins, we have fully constructed the semiotic bridge. We are translating abstract imagination directly into unyielding physical action. We've traced this incredible journey together, from a completely dormant internet status code through a brilliantly surgical chopsticks callback loop down into mathematically pure LIFO data trees, all the way to a physical robot dispensing cheer on a disk. The semiotic bridge from digital truth to physical reality is officially built. The only provocative question left to ask is, now that the bridge is wide open, what will you program it to do? Thank you so much for joining me for this explainer. Keep learning, keep exploring, and I'll catch you next time.